A journey into mind over matter, myths and reality. Telekinesis, the incredible and legendary ability to move objects with the power of the human mind. But can it be real? Let's delve into the science behind telekinesis. Telekinesis has a rich history, rooted in ancient cultures and the realm of myths and legends. It's a concept that has captured human imagination for centuries, even today, for example Marvel, LucasArts, etc. Physics perspective. According to the laws of physics, objects can only be moved by applying, literally, a force. This means, to move an object, you must exert a mechanical force on it. Electromagnetic forces. Moving macroscopic objects like 1 gram of iron would require significant electromagnetic forces to overcome friction, inertia, and other resistive forces. The human brain, in its natural state, does not have the ability to produce the immense electromagnetic forces required for such an action. Energy concentration. Now, let's assume that the human brain has the ability to generate and concentrate this energy for the purpose of telekinesis. To apply this energy to move 1 gram of iron over 1 centimeter, the energy would need to be focused on a specific location, which can be challenging considering the brain's size and the scale of the task. The energy required to move an object over a given distance does depend on the distance. In physics, the work done to move an object over a distance is directly proportional to the distance and is given by the formula W equals Fd. The energy required to move an object is equivalent to the work done, and it increases as the distance increases, assuming the force remains constant. In the previous calculations for electrons, protons, neutrons, and hydrogen atoms, the distance was held constant at 0.01 meters, 1 centimeter, and the energy required was calculated based on that distance. If you were to move these particles over a longer distance, the energy required would increase proportionally to the distance. Conversely, if you were to move them over a shorter distance, the energy required would decrease proportionally. So, indeed, the energy needed depends on the distance you want to move the object. So, if you want to move a single particle over a distance of 1 meter, let's provide the calculations for the energy required in that context for basic particles with mass. We will use the known nowadays to science values and formulas. Kinetic energy formula: E equals half mEV square. 1. Electron. Mass of the electron approximately equals 9.1093836 multiplied 10 in power 31 kilograms. Velocity equals d, t. E equals 9.1093836 multiplied 10 in power 31 measured as kilogram multiply, meter per second, in power 2. This will give you the energy required to move 1 electron over a distance of 1 meter in 1 second. 2. Proton. Mass of the proton approximately equals 1.6726219110 in power 27 kilograms. E equals 1/2 m underscore PV in power 2 equals 1.6726219110 in power 27 kilograms, meter per second, in power 2. This will give you the energy required to move 1 proton over a distance of 1 meter in 1 second. 3. Neutron. Mass of the neutron, m underscore n approximately equals 1.67492749804110 in power 27 kilograms. E equals 1/2 m underscore nv in power 2 equals 1.6749274980 asterisk 10 in power 27 kilograms, meter per second, in power 2. This will give you the energy required to move 1 neutron over a distance of 1 meter in 1 second. 4. Hydrogen atom. Mass of a hydrogen atom, m underscore h approximately equals 1.673538 asterisk 10 in power 27 kilograms. E equals 1/2 m underscore hv in power 2 equals 1/2 asterisk 1.673538 asterisk 10 in power 27 kilograms, meter per second, in power 2. This will give you the energy required to move 1 hydrogen atom over a distance of 1 meter in 1 second. In each case, the energy calculated is the minimum energy required to move the particle over a distance of 1 meter in 1 second, assuming a constant velocity. Let's take Mr. Magneto from Marvel with incredible ability to move and operate with metals. So to calculate amount of energy required to move 1 gram of iron, Fe, over 1 centimeter. We previously calculated that it takes about 5.5 times 10 in power minus 9 joules of energy to move 1 atom of hydrogen over 1 centimeter. Let's assume a similar order of magnitude for moving 1 gram of iron over 1 centimeter. So, to find the number of iron atoms in 1 gram of iron, we will use steps. 1. Calculate the number of moles of iron in 1 gram. This can be done using the molar mass of iron, Fe, which is approximately 55.85 grams per mole. Number of moles of iron equals mass, grams, molar mass, grams per mole. Number of moles of iron equals 1 gram, 55.85 grams per mole. 2. Once you have the number of moles of iron, you can use Avogadro's number, which is approximately 6.02214076 multiplied 10 in power 23 atoms per mole, to find the number of iron atoms. Number of iron atoms equals number of moles of iron times Avogadro's number. Number of iron atoms equals 1 gram, 55.85 grams per mole, times 6.02214076 asterisk 10 in power 23. Now, calculate the number of iron atoms in 1 gram of iron. Number of iron atoms approximately equals 155.85 times 6.02214076 asterisk 10 in power 23. This will give you the approximate number of iron atoms in 1 gram of iron. Energy calculations. Now, let's get scientific. To move 1 gram of iron over 1 centimeter, it would require a staggering amount of energy. 1 gram Fe approximately equals 10 in power 3 equals 1000 the mass of 1 iron atom. Energy to move 1 gram of iron over 1 centimeter. E approximately equals 5.5 times 10 in power minus 9 joules, atom times 6.02214076 times 10 in power 23 atoms per gram. Equivalent energy. To put it in perspective, the energy needed is equivalent to lighting up, for example, numerous 100-watt lamps simultaneously. An astonishing amount of energy is needed for this feat. Use the formula for power. Power, in watts, equals energy, in joules, time, in seconds. Let's convert this time into a more practical unit, say hours. Time, in hours, equals 5.5 asterisk 10 in power 9 asterisk 6.02214076 asterisk 10 in power 23, 103,600. This will give you the time approximately equals 9,200,492,827 in hours. It takes about a million years actually to use the energy equivalent to one 100-watt lamp. Please note that this calculation is purely hypothetical and for illustrative purposes, as the concept of telekinesis is not supported by scientific evidence, and the energy required for such an activity is not based on real-world physics. The impossibility of telekinesis. In reality, telekinesis, as commonly portrayed in stories, challenges the laws of physics. Our current scientific understanding suggests that it's highly improbable. Conclusion. The power of the human mind is incredible, but when it comes to moving objects with just our thoughts, we face limitations set by the laws of physics. In fact, people with insult or mental injury can't control even small parts of body electrical way. In the end, telekinesis remains a subject of fascination in fiction and folklore, but in the world of science, it remains a concept of imagination. Thank you for watching.